Alright, in this video I'm going to attempt to talk about the history of our project and catch us up to date with some of the current work that we're doing. And I'm going to splice these pictures into a, the format, idiot with a Sharpie format who thinks he's a genius. So, except for I'm not going to use a Sharpie on my whiteboard. I'll still be using the traditional Expo. So my parents bought a rectangular piece of land, roughly 2 acres, in the neighborhood valley. And they placed their house just right above center. The land they bought had a gentle slope going down towards the east over here, and then we got west over here. And they hired a bulldozer to come in and excavate as much material as they could go, as low as they could go, while maintaining a place for the French drain to actually drain onto their own property. And in this hill, that's where they built the slab that's where they put the slab that they started to build on. Okay. The slab was an oval shape, and it had a grid of rebar on 1-foot centers throughout. And through the form, rebar stuck out of the bottom, or stuck out past the form all the way around. And then on this oval slab, with the rebar sticking out the edges, they bent it up, and those pieces of rebar were the beginning of the dome, which they then tied the rebar to. That became the dome. Okay? That is an interesting story all in itself, because when you're designing a dome, whether it's a geodesic dome or ferrocement dome, you need to consider how much of a circle you're going to use in your dome. So let's say you have pretend that's a perfect circle. You have the option to have a half circle dome. You could have a 3/4 circle dome, whatever. You can have any sort of dome you have. So one is going to have a lot of head height. Another one is going to have a little less, and finally even less height. So my dad opted for more than a half a dome, more than a half a circle. And so the dome he built, this is the slab, it sort of comes up and out before it comes back down. So you have the opportunity to have some wall space, and you could hang a picture in there if you need to. The way that he framed, if that's the right word, this with rebar was kind of interesting. One of his neighbors, Randy Foxhoven, actually developed this. So if you have your slab, you break it into 6 pies, right? And then each pie has its own, or each third of it has its own direction which the rebar runs. Alright, following me there? And that causes a really interesting thing to happen. What if I got a straight edge? Whoa, goodness, no straight edge. Just follow me here. So you have all these pieces running like this, right? You have all these pieces running like that, and then you have all these pieces running like this. And then what you wind up getting is, on the top of the dome at least, you get all these perfect 1-foot triangles if you're spacing it at one foot apart. And that'll give you a pretty perfect triangle pattern all over here. And what that allows you to do is have a consistency in the thickness of your dome. Because if you just randomly are running rebar to shape your house, you might wind up with some places that would have, you know, 5 or 6 pieces of rebar crossing. And if each piece of rebar is 3/8 or 5/8 or something, you know, it can start to get pretty thick pretty fast. And having these triangles means you have a consistent 3-piece overlap at every point, everywhere throughout the dome, and no more and no less. And that lets you control the thickness of this dome. You know, it gets a little weird. It breaks down a little bit on the edges. So we've got pictures of all this. So let's say this is the you're looking at the dome like this, and you have pieces that are running like that, and then by the time you get to the edge, you might start having pieces that are running something like that, and then you have the pieces that cross over this way, and then whatever. So it can get a little funky on the edges, but it still is controlling the thickness of your wall. And now that they had built a dome, the initial rebar dome, it's not Ferrocement yet until you put concrete on that lattice work. They started doing little additions, and they added what we always call the yellow room, which was a little bubble on one side, and then they added another bubble over here, which was the dining bubble. And eventually, trying to figure out how to bury this place, we come to the current design where you have a retaining wall all the way across the front edge with various windows in it. This is the entryway arch, and all that becomes invisible. And then the retaining wall comes off to the edge, and that's what we're working on now, is the retaining wall. Where the front of the house actually looks like this. So let's take an imaginary look at this from an aerial. So we have the main dome, we have the yellow room bubble, we have the dining nook, and then we have the retaining wall. And actually, I don't know if it's flat or not. Okay. But anyways, you have the windows. You got 3 windows coming out of the retaining wall there. You have the main arch under there, and then the dome. The triple domes, right, like that. And then the part that I actually grew up in was a structure that comes off the side of the house, right here, where we have the bathroom and the kitchen and bedroom and porch and patio. And this part we never finished. Now, jumping ahead to the year 2007, I believe. We're thinking about the project, gearing up to start working again. And we're thinking about our experiences with these houses over the last 30 years and getting enough windows in there to make sure it's not dark, and just trying to make a positive space to live. And my dad decided, you know what, screw having an underground house, we're just going to go with an earth sheltered house. So he cut the top of the dome off that was still bare rebar. At this point we had concrete all the way around. And he folds it up and builds a lip that goes, you know, all the way around the dome. Oops, can't draw. Shaming my mom here. She's a Very good artist. There we go. There's a dome with a lip. A concrete lip all the way around, Ferrocement, and this is a I don't know, it's still an oval. It's centered in our dome. And we have the idea now of putting up dormered windows all the way around, and then some sort of roof structure of some sort. And we're sort of thinking of a round barn roof that's elongated into the oval, gabled up to the top, because that'd be flat. And then on that we could, put some sort of modified bitumen torch down roofing or something, or spray it in foam, or both. And so if it was a spray foam roof, the spray foam would give it a texture that's kind of familiar. It'll keep the aesthetic of the Ferrocement going. This video is really getting out of sequence timeline wise, but I'm doing my best to explain what we're doing here. So, moving on. We have the triple dome complex with the retaining wall, the house with another retaining wall, and I guess the house actually connects into that. Whatever. So now we have to install our French drain, because since this is built into a hill, we need to get the water that migrates to the back of the structure away. And basically we built a French drain that collects all the water from the wood part of the house has a cinder block wall that goes into a Ferrocement retaining wall that ties into the Ferrocement dome with the bubble, and then the French drain comes around and it comes underneath the retaining wall on this side through our yard, all underground, and then one of these pops out sooner than the other one does. This pops out right by the edge of the property, and this one pops out about 30 feet to the edge of the property. Another feature of the French drain is, if you remember, we have the dining room bubble with its 3 windows and the retaining wall coming around like that. And then we have the main entrance. So the big bubble, little bubble. Alright. So the French drain comes around in its little trench, comes down and out, but then also the French drain ties into all of these earth tubes that we have, because all this will be filled with dirt to give us our earth shelter all the way around. And then also, since we have a bathroom in here, the septic tank and leach field. So we have our tanks here, and then our leach field over here. The story goes with the septic tank is it was Christmas, and my parents were at my dad's mom's house, and my mom's opening up a present from my dad, and she unwraps it, and it's a toilet seat. And my family was like, "Oh, Ray, what are you doing?" But what that meant was that my mom was finally going to get a flush toilet, and that was rumored as to how she learned that we were putting in a septic system soon. I don't think I was born when the septic system went in, but I was around for the leach field. I mean the retain. Oh my God, I can't even speak. The French drain, because that was from our 2007 work. So let's go ahead and write that down. And then the septic was, I don't know, probably 1982 or something. I have no clue. Oh yeah, so this house, we were off grid until I think 1996, and we brought electricity in as a community a big group buy because they had to run the lines in and send it all through the neighborhood. But we were legit off grid until then. So the majority of this work was done with solar panels, deep cycle batteries, and generators, and a gas powered concrete mixer. And then in '96, you'd think that we would really be benefited by this, but around the time I went to high school, that's when my dad moved into town, and so this project sat dormant for a decade until we started to bury this thing. And then finally, when we got to burying it, a lot of these houses in the early days were buried with just a product called Ferrocement, which was just like a whitewash paint on concrete based waterproofing, and it works really well. You do the inside and the outside, and it works real well. But eventually, it wears down, and 15, 20 years later, you start to develop these little leaks. And anywhere in the Ferrocement where maybe there was a piece of rebar or something that wasn't packed in real good, so you have rebar and you're smashing the mud into it, and then there could be a little channel. And, finding leaks on Ferrocement can be real tricky because you might have say this is your dome, and you have a piece of rebar that wraps around it or something, and so you have a leak over here, and the water might travel through a hollow space near your piece of rebar and then leak over here, and so you'll be painting the Ferrocement on here and just trying to find that thing until eventually you cover the whole thing and you might fix it. So anyways, we were experimenting with various types of waterproofing, and what we settled on was we painted the dome first with the Ferrocement. So we painted it 2 times. We had a white Ferrocement that we painted it, and then we had a gray Ferrocement that we painted it. And then we used a butyl rubber, a paint-on butyl rubber, and that was our 3rd coat of waterproofing. And then in a 4th coat of waterproofing, we used these big, I don't remember what kind of rubber, but these big sheets of rubber that we draped across the outside. And then a 4th layer was we used styrofoam 4x8 sheets that we layered on the outside like shingles overlapping as an insulation. So we really threw down a ton of layers of material. But some of these houses had a real struggle with water, and what a lot of people wound up doing in the community is you have a Ferrocement house that is fully buried and starting to leak. Are you gonna go through the effort of digging up your house and pressure washing it clean and then figuring out where the leak is and whatever? That's a lot of work. So what a lot of people did is they wound up building a house on their house. So you have a Ferrocement structure that's under the earth, and they just would throw up metal roofs, a metal roof to deflect all the rain away from the house and keep all the soil around it dry and everything to prevent the leaks. So we're going to try real hard to absolutely prevent having to build a house on our house, and that's why we're going through the effort of all these layers of waterproofing. And now that my dad has a little more money to throw at the project, the waterproofing from here on out was going to be, this is the dome layer. We're going to do the Ferrocement 2 layers, and then we're just going to use spray foam. And so right now we have places where this is the edge of the dome, and we have the sheets of styrofoam, or insulated board panel sticking out of the ground. We have the earth there. What we're going to do is we're going to dig a little trench out, cut off all the stuff that's been sun damaged, and then we're going to spray the foam overlapping like that, so it'll be a continuous piece. We're not going to dig up anything that we've already finished because we're confident in all the layers of waterproofing that we've done. But another feature of the earth sheltered house is we want to protect the thermal mass of the dirt going on our house. So if we have, this is a side view, this is the dome, and then we have the little windows or archway going out, and this is our retaining wall. So that, you know, this is the air, this is the house, and then over here is I can't spell earth. Sorry. And then we're going to not only spray foam on the dome, but we're also going to spray foam on the inside of the retaining wall. And this way, all the sun that it hits the wall and is baking the concrete won't change the temperature of the earth so quickly, and hopefully that'll allow us to coast through a good portion of the season before, you know, the air conditioning in the house has to overcome the heat of the earth. You know, and that's just sort of a normal cycle of any underground or earth sheltered house is at the end of the season. You know, you're going out of winter, the earth is cold, and you're going into summer, and that cold earth is going to lower your heating, your cooling bill for the summer. Then at the end of summer, the earth has gotten hot, and it's going to lower your heating bill going into winter. But the in between times, when it's the earth is cold and your house is cold, it's going to work against you slightly. So some buffer of insulation there. You know, I haven't done the calculations myself, but one of my neighbors out here, who's a real honest to God engineer, he's an airflow engineer, but he's good with math. He calculated, I might have the numbers slightly wrong here, that if this is your dome, this is your 3 inches of foam, and this is all your earth, that 2 or 3 inches of foam here going against the earth, which is a consistent, you know, I think it's 77 degrees Fahrenheit in our part, that the energy efficiency is equivalent with this setup as an R70 super insulated house. So in theory, we're going to be able to build a dome with minimal materials and a lot of man hours that functions as well as the most modern of super high efficiency, super tight houses. We of course won't know if it worked out that way until we're done, but you know, a boy can dream. Anyways, I'm not real sure what I've left out of this video. I'm just going to wrap it up with this. The next video is going to be a work video, and I'm really excited about getting back to that. You know, the very first preview of this series is going to be more similar to the stuff going on from now on. But there's still a few other things for future videos that we can talk about. One is the various types of houses. Let's do a little preview of that. So the Ferrocement houses that I'm familiar with in the 2 communities that we have here in north central Texas we have the Grand Dome. You know, I call it the Grand Dome. You know, there's big dome houses where there's seriously just a dome shell, and that's what where the strength comes from, is the dome. And then there's others where are the reinforced rib houses, where they're a little more similar in how you have like a living room and a kitchen and you know, bedrooms or something, but they have these ribs or these beams, these engineered beams with bent rebar on the outside of the low-lying roof of the structure. and so they have an exoskeleton that holds them up. That's more of the original Bob Foote design. Those are pretty cool. And actually, just yesterday, I was out exploring a house at our sister community, Rainbow, sort of trying to do some reverse engineering, archaeology type stuff on it. And then there is the freeform house. Some of the houses were doomed to have trouble because they were just so wild, so free. And one addition is my dear sweet friend Terry Sheelar. He did an addition to his house, which was a regular, dome room house with no ribs, and he would, I don't know how he planned on burying it, but he put these little things on it to hold the earth, because I think he was planning on doing this, and then he'd have little protrusions where windows would stick out of it, and I don't know how he planned to hold the dirt on it. He got cancer and died before he ever finished his house. So I'm not sure what his dream was, but he really was just sort of winging it and free-forming it. And I worked a lot on the crew on that house, and it was cool. It was fun working on it. But was he gonna build little terraces and hold dirt onto the house? I just wasn't real sure what his plan was. My dad always modeled everything. I mean, he modeled the dome. He just ran little pieces of wire, and he modeled the dome. He modeled the several models of the roof he wants to do on top of the dome. We've done several models of an addition and expansion to the wood part of the structure. The wood part's in pretty rough shape now, because in 2007 we were going to tear the wall out and expand the house, but my dad's girlfriend at the time wound up getting Lou Gehrig's disease, and that sort of ended that project there. So I don't know. It's a story of decade on and decade off. So from the 80s through the 90s, did a lot of work, intermittent as it was, and then from around 96 to 2007, relatively nothing happened. 2007 to 2009 did a lot of good work, and then 2016 we started farting around with it again, and that should catch us up. Okay, enough rambling from me. Thank you so much for your time, and the videos that follow will be much higher produced than this one, and it won't be so meandering and boring. I promise. But I just wasn't sure how to catch us up. I wasn't sure how to time travel without talking my way through it like this. All right. Thank you. I love these little earth columns. I mean, that's what we're doing at my dad's house, is these same earth columns.
Well, yeah, and Robin was telling me that this big earth column on the end, I wanted to just cap it off and do styrofoam, but he said this floor is falling an inch or two here in this bedroom because it's supposed to be there to hold up this end of the house.
Yeah.
Do you know what I mean?
Yeah.
It's the way he said, the design. And so I'm going to go ahead and let him do that,
But these beams,
Yes.
I love these beams. I've never built a Ferrocement beam.
Beams, you get pictures of them before they're covered up, all of them, because it's definitely documenting.